Hello everyone. In this video, I would like to continue with the previous video, the one that make an introduction to logarithm and how to use calculator with the simple common logarithm and the simple natural logarithm. And I believe that we stop around here, this question, example number 3, where we raise e to the exponent negative 0.5. And I would like everyone to use the calculator to make sure that you come up with a number. And also I would like everyone to make sure that you know how to operate the natural logarithm key, put in natural logarithm 0.18, and then you should end up with this number. So it's good to practice with the Casio FX991MS. Alright, so let's continue. Um, uh, I would like to provide you with some reference for this logarithm lesson. I just want to let everyone know that logarithm is not as simple as we summarize in this one lesson or two lesson. What we are going to concentrate on in this class is these formulas right here. Alright, so you have natural logarithm, and the argument of it also is the e to the exponent of x. And as you recall that if I break this into log of the base e of e to the x is also equal to x, because the base of my argument is the same as the base of my log, right? So you have an argument here as a power, and the base of the power is the same as the base of log. So in this case, it's more like the elimination process here. So if you run into a case like this, your answer should be equal to x. And we have proven that as well. We have proven it using the definition of the logarithm and exponential function. Then if I take e, I raise to exponent x, and it's actually equal to e to the exponent x. Alright, so this is actually very important in our next lesson. So I would like everyone to keep that in mind. Okay, so I also want to emphasize a few essential formulae regarding properties of logarithms. This is probably a very good reference later on in any advanced mathematics that you are working with. And also to show you that logarithm is not as simple as just a few click on the calculators or the conversion that we will be using and learning in this class. And there are many useful operation involving logarithm which we can use in order to solve for the exponential equations. Okay, so and I think it's also a good idea to mention that this formula is right here. Okay, this formula. Okay, and I will get back to that formulas in a minute. And before I go to these formulas to show everyone how important it is, then just to review our natural logarithm, because we mostly use natural logarithm in this class. Make sure that you remember ln of 1 is equal to 0. So why do we have that? We can make a quick proof right here. Okay, so I have a natural logarithm of 1 is equal to 0. Okay, so as you know, natural logarithm is the log of the base e, and writing 1, I can write e to the exponent 0, because anything to the exponent 0 is equal to 1. So the 1 is converting into e to the exponent 0. Why I am doing that is because I want to use the properties where I just proven above here for everyone. Okay, so if the base of your log is the same as the base of your power, and this power is your argument, then it's more like the elimination. You can just conclude your answer is equal to 0 in this case. Therefore, I have this equal to 0. You see, and this kind of the same. Okay, and that eliminate that part, and your answer is equal to 0. And you can also use your calculator to put in ln of 1, and it should be equal to 0 as well. Okay, so I make a quick proof for everyone here. Alright, okay, so ln of e is equal to 1, and it's the same thing as log of e to the exponent is equal to 1. And in here we have ln of e to the exponent n equal to n. So it's the same concept. Okay, so just remember where all of this formula is coming from. And I don't think I will go over the properties of logarithm. It will take the entire unit to work with this, to master it. Alright, so just keep this in mind. Okay, this operation is important, where you will have the base of your log is the same as your base of the argument. Then you can just conclude the whole statement will be equal to your exponent. Alright, okay. Let me see if I have to cover anything else. I think, why don't we review our calculator? As you see, we learned all this in previous class. Make sure that we avoid the concept of getting the syntax error. And let's try it again with the ln of 1 to see if it's equal to 0 in this case. Okay, so you have the calculator in front of you. You can just put in, as I am doing right now as well. Okay, so you can key in this key. So it will give you ln. And then I will put in 1. Okay, I'm sorry. Okay, so let's zoom it back. So ln of 1. Okay, and press equal sign. I should have 0 as the answer. Okay. Okay, so I don't think anything else I should be mentioned for this particular handout. I am quite confident that we cover all the basic ideas for logarithm and natural logarithm. Oh, okay, I think I was mentioned to everyone that I would like to go over these formulas. Okay, so it's very interesting. Okay, so let's work with it right here. I would like everyone to recall that in previous video, I mentioned this. I mentioned that on our calculator, you have a common logarithm, which is the base 10, and you have natural logarithm, which is the base e. Alright, so what happens if you want to calculate log of the base 2 or log of the base 5? And do we have to go to the book of logarithm to find the table and look for that? Or what do we do if we just have this calculator where the key on this calculator is just log of the base 10 and log of the base e? So one very unique concept is to use these formulas. So let's say I have log base 2 of 5, okay, and I want to calculate this. So what I will do is I will take natural logarithm of the 5, and I divided by the natural logarithm of 2. So this will give me the solution for this particular one, not having the base 2 as log on my calculator. Okay, so if you translate this questions, or I mean these formulas, you see that it's a log to the base 10 of n. And here I will take ln of n. I divide it by ln of 10, right? So in this case, I have the base 2. So 5 is my argument. So that is a ln of 5. And as a denominator, is a ln of 2. Is the ln of your base. So if you ever want to calculate a logarithm with a base other than 10, and E, you can refer to this particular formula. Alright, I think I say all I need to say. Alright, okay. And if I need to come back to any of these formulas in our next application uh, lesson, then I will go back. Alright, thank you everyone.